Hello everyone, and welcome to today's chem lesson. Today we are going to spend a little bit of time talking about density, which should be something that's a little familiar to you. Right? It's something that gets talked about a lot in elementary and middle school science. You probably talked about it in any other high school science class you may have taken. But we're going to dive into and refresh ourselves a little bit on how density works. Now, density is a measurement of how much stuff fits in a certain amount of space, how much mass can be packed into a certain amount of volume. Every type of matter has a different density, right? Because every type of matter has its molecules and atoms packed into certain volumes differently, right? Let's say we have here two masterfully drawn, perfectly identical boxes. Alright, these two things have the same volume. Right? Because they're the same. If I wanted to show that these two things had different densities, if they have the same volume, one would need to have particles that are packed closely together, right, like this. Here, all of these are packed closely together. And then this, if I pack those molecules less closely together, this would be something that had a lower density. Right? The more matter you can fit into a certain amount of space, the more dense a substance is. Right? So when we take something with a high density like steel, we see something like this left example, where there are a lot more particles, a lot more molecules, a lot more atoms packed into the volume. Right? There's not a lot of empty space in here. On the other hand, something with a low density, your things like cork, certain plastics, paper, those are things that are not very dense. Right? They have a few molecules, a few atoms packed into that space, and there's more of this empty space that we see. Now, if you're looking at something and you go to pick it up and it is heavier than you expect it to be, that is a signal that you have a denser object. If you go and you pick something up and it's lighter than you expect it to be, that is the signal that you have a less dense object. But picking things up and saying like, oh, that was heavier than I expected, oh, that was lighter than I expected, that's not a great way of determining density, right? That's not a super scientific way of determining density. We have mathematics, right? We've got measurements we can take, we've got things we can do to better find density, to better calculate density. The density of any given object is a ratio of its mass to its volume. Right, so you're taking the mass of the substance, you're dividing it by the volume, that'll give you your ratio, that'll give you your density. On top of that, if you've found the density of a substance, you can use that density to help identify other samples of that substance. Right? As long as a substance is pure, the size or shape of the sample will not matter. The density will be the same. So if you have a paper clip that's made of steel, and you have an I-beam that is made of steel, right, those substances will have the same density. If they are both made of pure steel, then it doesn't matter. Right? A necklace made of pure gold and a solid gold bar from Fort Knox have the same density because they're both pure gold. Right? So density, finding the density of something unknown and then matching it up with a list of substances that you know the density of is a way of identifying your mystery object. Right? But again, you need to find the density before you can do anything with it, and the way we find our density is by looking at mass over volume. The formula is on table T, the very back page of the reference table. Right? It's never going anywhere. You never have to memorize it. It will always be there, and it will tell you that D stands for density, M stands for mass, and V stands for volume. Right? Let's ease our way into some practice problems. Which is more dense, a pound of rocks or a pound of feathers? Now, I'm sure some of you see this and you think it's a trick question. Right? They're both a pound, you say. That's not how. This question has no answer, right? They're both a pound. But the trick question is when people ask which one is heavier. Both of these things weigh a pound, and neither one is heavier than the other. But when we talk about density, we want to know which one of these things has more mass packed into a smaller space. Since they're both a pound, we can say each one has the same mass, but if they have different volumes, they have different densities. And like you're pointing out in the chat right now, rocks will have a smaller volume, which means they will have a higher density. Right? The rock, a pound of rock, fits into much less space than a pound of feathers. Right? Still not a very scientific way. Right? Still not a very mathematical way. Let's look at some more mathy problems. Up here at the top, I'll remind you that density is equal to mass over volume. And I'm going to give you 30-40 seconds to work on these. Remember, you can pause the video and take as much time as you need, but it's not good YouTubing to leave a bunch of dead space. Right, so 30-40 seconds on the clock. Again, pause if you need more time, and then I'm going to go over some answers. So, let's look at our answers here. First, we have a 10 cubic centimeter sample of copper with a mass of 89.6, and they say, what is the density? So if we're plugging in, we know density is the variable we're looking for. We have two pieces of information. We've got the 10 centimeters cubed and the 89.6 grams. We need to figure out which one of those is mass and which one is volume. They tell us a mass of 89.6. They tell us the unit of grams, which if they didn't say mass, we could recognize as a mass unit, right? So 89.6, no matter which way you slice it, is going up top, which means 10 centimeters cubed is going to go in our denominator. We're going to divide out and get our answer, 8.96. But when we want to do our units here, it's not just grams, it's not just centimeters cubed, they actually both come with us, right? They don't cancel out, there's no cancellation of units, and so we get grams per centimeter cubed. They stay exactly the way they were. In our second problem, they give us some dimensions, they tell us the mass is 94, and they ask for the density. And so we're going to do a very similar setup to what we had before. This time, though, we have to calculate our volume. And when we plug this in, we're going to get a number. And that number is going to be 7.83 repeating. Right? And I picked this setup for a specific reason, right? You can write infinite threes after this number. Right? That's what it means, 7.83 repeating. You could also, mathematically, put a bar up here. But in chemistry, we're actually going to do neither of those two things. Because this density is a measurement. And because it's a measurement, that means we're looking at things with significant figures. 94 grams is something that was weighed. It's specifically not 94.0 or 94.00. Right? We got 94, which means we only know the tens place and the ones place. We can't go further than that. Same thing here. Here we only have one significant figure in each of these things. We can't end up with an answer that has infinite significant figures. And so, what we're going to do is instead of putting the bar and instead of putting infinite threes, we're just going to round. We're going to round to the hundredths place. 7.83 grams per centimeter cubed. What about this one? All right, what about this set of problems? Again, I will remind you density is equal to mass over volume. Again, I'm going to put about 30 seconds on the clock to work through these problems, and then we'll go over them. Remember, take your time. Pause the video if you need more time. All right, let's take a look. Our first question here gives us a volume, gives us a mass, and asks us to find the density. All right, so we're rinsing and repeating what we've done before. We have our mass of 306. We have our volume of 22.5. When we plug in, we're going to get a nice even 13.6 as our mathematical answer. And as far as our units go, grams and milliliters don't cancel out. Neither one is the same as the other, and so we bring them both with us. Grams over milliliter. It stays exactly the way it was. Our second problem asks us to find the density, gives us a volume, gives us a mass, and so we're going to, again, find ourselves plugging things in the way we have been. We're going to get an answer here when we plug in. That answer is going to be 1.84. Again, there's a lot more that comes after it in the calculator, but these are measurements with significant figures, so we're going to round to the hundredths place. And we are going to call this, again, grams per milliliter, right? Those units don't cancel. And in our last question here, we've got a weight. We have a density, and they're asking us to find the volume. So here, we actually have a different setup. We're looking for volume. We're looking for this denominator. In order to do that, we're going to have to cross multiply. Right? Put our 10.5 over 1. Cross multiply to get 10.5 grams per centimeter cubed times volume equals 2,500 grams. To get volume alone, we have to divide by our density. Right, cancel out. We've got volume alone now, and that's going to be equal to this weight divided by this volume. Or, sorry, this density. I don't know why I didn't take it the whole thing over. Alright, so we've got mass divided by density to give us our volume. When we plug this in, we're going to get a nice number. Or it's not very nice, actually. 238.09, which we're going to round to the hundredths place, so 239. Sorry, 238.10. And then we need a unit to come with us. And for our units, I'm actually going to clear out this up here, and we're going to move our unit logic to this little spot. And we're going to talk it through. All right, let's see. What color have I not used yet today? Let's go this blue. We're going to move this up here, and we're going to talk it through. All right, we've got 2,500 grams. We've got 10.5 grams per centimeter cubed. The numbers we can work out. The numbers work out fine. 238.10. But grams per gram per centimeter cubed is still our units here, and that can be cleaned up. So we're going to isolate. We're going to take these units and see what we can do with them. Grams divided by grams per centimeter cubed. Now, if you remember from math, if you have a fraction in your fraction, you're not going to divide. You're going to keep, multiply, and flip. And simplify as best as you can to solve this out. Now, grams divided by grams, it cancels out. And you're left with centimeters cubed over 1, which is the same thing as centimeters cubed, to put at the back end of your answer. They asked us to find volume, and so we need a unit of volume, which is centimeters cubed. So that checks out, it makes sense. And if we look back at our mathematical thinking here, that also checks out and makes sense. To wrap us up for today, I've got one more practice problem. Which of the following is more dense? A steel paperclip or a steel girder? Alright, I cannot pull one over on you. These two substances are both steel. And since they are the same substance, they will have equal densities. Well done. From here, I'm going to transition us over to our Zoom meeting for questions, comments, concerns, attendance, announcements, and all the other fun things we have to do. And I will see you there.